Yeah, so I hope you enjoyed your lunch as we did, and yeah, welcome to the presentation. We will talk about how Google App Engine can shoot a startup beyond its horizon. And yeah, don't make it boring. Come to a journey to the outer space. So as I said, this talk will be focused on startups. Any startups here, or you once maybe found a startup or something like this?
I want to have one.
You have one. Oh, you want to have one.
I want to have one.
Okay, yeah, that's cool. So I think the talk is quite good for you. So my name is Robert Schmidt. I come from this Wire. It's a small, fresh company, software development. We are pretty in stealth mode right now, so you will not probably find much information about us. So our first product is called Campo Kickers. It's a football manager game, free to play. So I can encourage you just to check it out. It's quite cool if you love football. Yeah, and with me, Jens will be presenting some hot stuff from directly from Google.
All right, yeah, I'm Jens, I'm from Google. I give a little bit of an introduction like this, so yeah, I'll let Robert do
yeah, so he will join the presentation later on. So yeah, let's start the journey. And where the journey begins for all the startups is you have a team, you have an idea, and maybe some money, and there's some energy, you know, and then you get the big idea and get to the point, okay, we make a great product, but not something that great or like that, but something really, really big, like for example Campo Kickers, you know. And the mission of the great product isn't trivial, because when you have the money, when you have the people, when you have the idea, there's still a big issue with the technology. So how you come from the planet Earth to your big red planet out there. So there are some points which you have to address. And when you develop the product, there are mainly two phases in which you are, and depending on the phases, there are different constraints which has to be met by the technology. So, for example, at the beginning, you want to have the possibility to rapid prototype stuff, to be flexible, to be cheap, and because of the fact that you want just focus on the product, you want that you don't want to maintain the whole technology. Okay, so you just want to focus really on the development. And it is opposite to this in the final product. Some other points are more and more important. So, for example, when you have customers, when you make money, it's much more important that you have a scalable stuff, that it runs stable. And when you get bigger and bigger, it's very important that your technology also has the possibility that it's extendable. So, for example, new technology is coming in, and you want to be able to use it, and therefore it's really, really crucial that your technology stuff and the infrastructure is able to do it. And of course, maybe at the beginning, you don't want to bother with the technology, but maybe when it comes bigger, you want the control back. So as you see, that are some contrary constraints depending in which phase of the product development you are. So as you see, the horizon for a startup to create a real cool product and to create a product also to be future-proof, it's really big. Yeah, but there are some spaceships for the to reach your dreamed planet Red. So there are mainly three options where you can go. So you can start and build everything by yourself, of course. So you buy the hardware, you buy the maybe you have to rent a hall to put the hardware in. You need to set up the system, you need to install the software, you need to administrate the software, you need to take care about the security constraints, for example. So it's a huge task, and I don't want, unless you are a startup that is interested in this stuff, you don't want to do it really. So thank God we have something like infrastructure as a service right now. So you can just get the hardware virtualized, so you don't have to bother on the hardware, but still you have to install the system, keep it up to date. You have to still install the databases, maintain the databases, keep track of the security issues, and so on and so on. So it's still a lot of things to do that you probably don't want to do if you are a startup and you want just to focus on your product. So a dream would be, of course, that you can really somehow abstract the whole infrastructure and just focus on the important stuff. So back in 2011, I was actually looking for this dream platform, and yeah, I asked Google, yeah, how can I come from my planet to my dreamed planet Red? So it answered me just simple, yeah, your rocket is ready, sir, you know. So and it's called Google App Engine. So Google App Engine is something like a platform as a service. So you have everything ready. You have all the hosting, the app servers, you have all the systems, the databases, everything is set up for you. And you don't have to care about installing it, you don't have to care about updates. For example, now as you heard about heartbeat problems, so for example this all stuff will be done by the Google App Engine engineering team. And yeah, it promised me also that it will auto-scale with our product, that it will be easy to maintain, easy to build, and so on. So and that I will have a minimal administration issues with it. So of course it sounded really cool, and I have Googled also for the buts, so with 1T I mean, so are there any drawbacks, you know? So of course there were some, and I will talk about it a bit later. But let's take a look on the architecture of the Google App Engine itself. Are you more technical oriented or business oriented? So who's technical oriented? Okay, so we will go a bit in deep here. So how it works. So as you see, you have mainly 3 tiers, I will call it. So you have a scheduling and balancing tier, you have some computation tier, and you have some data storing tier. So this would be the core of the App Engine. And where the magic is done is here between front-end instances and scheduling balancing. So front-end instances are nothing else like virtual machines. So as your request rate increases and there are coming more and more traffic inside, so the Google App Engine will see it, will have some algorithms, and will ramp up the front-end instances. You know, so it's you don't have to care about it, how the peak will be at 9 AM or 5 PM or something like this. You don't have to be prepared on this. Everything is done automatically by Google App Engine. So even from 1 second to another, or in 5 seconds, Google App Engine can really ramp up thousands of instances. So here the magic is done. Then, because of the fact that front-end instances can just handle the requests in 30 seconds, when you need some longer computations, you have like task queues where you can asynchronous push the tasks without any requests, and you have backends, so it's like a normal server that's running infinitely. And for the data store, you have also many possibilities. So you have the NoSQL and SQL databases ready to use. As I said, you don't have to install anything. And we are currently using the NoSQL database, and it's really handy because with the libraries that are up there, you can really easily put your data into the tables without having the troubles about definition of schemes and so on. And also later, when your data model maybe changes, the schemes, you don't have to update the schemes. You just can change your class and Google App Engine will handle it for you. And for the development stuff, there's or the development environment, you have the possibilities to use Java, to use Python, Go, and PHP. So there's really a broad range of possibilities you can use. But Google App Engine isn't just about the core. What makes the life of a startup pretty simple. It's also there are many services around it which you can use and which are also available just out of the box. So, for example, you have a Memcache service already, also ready to use. So it will help you to get the database contention much lower. You have also a file system where you can store all the files, and you have also a bunch and dozens of APIs from Google, which also you can use just like that. So it's, for example, the user API for authentication, search, images API, and mails, and so on and so on. So there are really many APIs out there, and there are also many services which connect really without any problems with your Google App Engine. So, for example, when you need big data analysis, for example, as we are doing it, we are taking almost every click of the players to keep track, okay, where do they drop off or something like this. And therefore there will be much data that you have to analyze. And the big query is the possibility, and you can just use one call to get the data to the big query. I think Jens will talk also a bit about it. So it really looks like that, not only just the core. For startup, it's essential to have the possibility to handle it, all the services, because they are maybe useless if you can't handle it with your resources. So here you also get great tools for it. So you get plugins for Eclipse, for example. So you can just install Eclipse, install the plugin, and write some lines of code, push a button, and you have your application uploaded in like 2 minutes. So you don't have to pay even, or you don't have to somehow order a hosting. You don't have to install stuff or nothing like this. You can just register for App Engine, install Eclipse, install the plugin, and just go. And beside this, for example, as I said, it's crucial that you are flexible in your development at the beginning. So you don't know how the features you are developing are behaving or how they are performing. So you want to have a framework maybe where you can put 2 versions of your apps and just make A/B tests. And the possibility is there. So Google App Engine is providing app versioning, so you can have multiple app versions run in parallel on one database. So paired with the traffic splitting tool, where you can say, okay, 50% of the traffic goes here and 50% of the traffic goes to the version B. You can easily maintain A/B tests. Yeah, so it's really perfect for the flexibility. Okay, this stuff is monetizing good, this stuff is monetizing bad, so we just put all the traffic on this version. And because of the fact that you are a startup and you have limited resources, we, for example, don't have any administrator in our team. Google App Engine comes up with a quite neat administration panel where all the services you have in one place. So you can see in real time how the hardware is behaving, how much does it cost, what are the logs. So you can get rid of bugs really fast. And everything is packed in one administration panel. So as you see, it's something like this. So you can see also in the last 3-5 days how the loads was, and so on and so on. Are really pretty cool stuff. About the constraints and the drawbacks. The main drawback of Google App Engine is that because of the fact that you have out of the box everything, Google had to define somehow the box and the dimensions and what comes in and out. So there is just a Java runtime environment subset available. So you don't have available all the packs which are in standard Java. So for example, the net package is quite is not there. So for example, when you need sockets, you cannot use them straight in Google App Engine. So there is something like called Channel API, where you can put information from the server to the client. So it's possible, but there are also Google is also facing this problem, and Jens will also talk about it. This is the main limitation, and there are some also hard limits on the database, for example, where you can store the entities, for example, at the maximum of 1 megabyte. So you have to care about how you are designing your data. When you know the constraints of this model, it's easily to follow it. So when you have, for example, this limitation of the 1 megabyte, you just make sharding. So it means you represent one entity as shards of objects. So for us, as a non-real-time game, it's perfectly fit. When you want to make a real-time game, Google App Engine is maybe not the way to go. But there is also the infrastructure as a service solution from Google called Compute Engine, and you can go there, for example. And the most interesting part, I think, for startups are the costs. So Google App Engine is you are built as you use. So there are all resources you can use. For example, database and computation time. You bill for everything. You are paying for almost every read, every write, and so on and so on. So it is quite complex, maybe. But on the other side, you see what are you paying for. And what's most important for us is that because of the fact that because of the fact that you use it and see it real time, how the costs are evolving, you can just start when you're starting the development. You can focus also on the performance. So you see from the beginning on, okay, this call or this operation is really cost intensive. And you can avoid this because you see every cost that are there. So I don't know if you are programmers and you were programming with databases. It's usually that when you write a query, you just don't think about, okay, it's performing for me, it's performing good. But when they come, for example, 10 users, 100,000 of users, you don't even know maybe how the one query is behaving. And when the one query is, for example, in a for loop, it can be really disastrous. So the constraint that the pricing is really per every write, per every read, makes us to think about the development from the beginning. And what for us was one of the arguments that we use the Google App Engine was the free quota that you get. So you get, for example, 28 instance hours per day. It means that one instance can run the whole day and you have a buffer of 4 hours when, for example, another instance has to be ramped up. And when it comes to the costs and the future of the costs, due to the war between all the cloud providers, it's really good right now because the prices are dropping constantly. For example, last month the price for Google App Engine dropped by 30%. Many services were set or are now for free. For example, 2 months ago you have to pay for every mail that you send. Now all mails are for free. So that's a good evolution, I think, for every startup, and that makes also me to get better sleep for the future. And I don't know, many of you or all of you got startup packs in your bags, so check it out. 500 bucks. I think 500 of these packs were given away.
Yeah, if you don't have one, I have a few more with me, so you can come to me.
So
it's like a voucher code.
Yeah, so it's also really great for the beginning, because I don't know if you could imagine how many does the development cost, for example, of our game. The first 6 months where it cost us $5. So we were developing with 8 developers. We were really using it intensively, and we paid just $5 when we had no users inside. So it's really cool stuff. You cannot compete with it. And right now, of course, the price, the costs are increasing as the users come, but because they are scaling with the users, and hopefully you have an application that monetizes with the users, it gets better and better. And it's really the perfect start for us, or was the perfect start infrastructure for us. And what I want to emphasize once more is that you have to code properly for having the costs at reasonable level. And so, because of the fact that you are using Google App Engine and you are used to that Google App Engine does everything for you, it doesn't mean that you can also outsource the brain of the coders to Google App Engine. Okay, so it's really crucial that the code is written properly. But when you get familiar with it, I think our developers needed, I think, 1 month or something like this to get familiar with it. It's not a big deal to follow the design rules of Google App Engine. So as you see, or as you saw, these 4 points are checked. So you have a really an environment where you can really rapidly prototype applications, where you can flexible change stuff, which is quite cheap at the beginning, and you need no additional administration resources. So for the minimum viable product, the perfect start. What about the points for the final product? So at this stage are we now? Our game has a couple of thousands of players, and now we want to go to other markets. And it's crucial, of course, that when the players on in, that it just runs. Yeah. So what about stability, scalability, extendability, and controllability? So in terms of stability and scalability, I think Google is a synonym of this words. You know, I think if Google will not provide stable and scalable hardware, no one will. So you are on the right track using this. And the Google App Engine runs actually on the same hardware as Google uses for their services. So you can be sure that you have almost 100% of availability there. Also in terms of data, because your data is replicated among these data centers of Google. So when one database crashes, your data is still available. And you don't have to care about it. That's the great deal. And yeah, you see also real-time panel. What is the availability of every service? So it's really cool and makes you sleep well. And the other points, so how you can extend the Google App Engine and how you can gain some of the control you lost through the constraints, Jens will present. So.
All right, thank you, Robert. All right, hello again. I'm Jens from Google, and I work in the Berlin office. I'm working as a solutions engineer on the Google Cloud Platform team. I will tell what Cloud Platform all is right in a few minutes. I started my Google career as a network engineer, so if there's any network engineers here, I love to chat about this stuff. But otherwise, I'm going on, and I work now on the Cloud Platform for a bit over a year. So first I want to tell what is the Google Cloud Platform and why should you care if you care about App Engine, because it really integrates well with the other products from the Cloud Platform. So when you use one, it's really easy to use the other ones as well. And this starter pack you hopefully got, or you will get from me after if you want. The $500 credits are for all the products, so you can try them all out for 3 months and you won't get charged. We kind of divide the products into storing, computing, and other services. And on the computing side, Robert talked enough about App Engine. Compute Engine is basically virtual machines in the cloud. You can have anything from less than 1 core to 16 core machines. So if you really need to run some big background computations, or maybe you like Apache Hadoop and want to run your own Hadoop cluster, this is what you can do on Google Compute Engine. Then Robert touched quickly on Google BigQuery, and this is, I think, for gaming the other most interesting product, because it allows analyzing huge data sets in seconds. And not only huge, also small data sets, but the thing is you covered whatever you need. You don't need to say before, okay, I need this much capacity, this much server capacity. You just put your data in, and you can stream up to like 100,000 records every second. Well, if you have that, you're really, really lucky. If you have 100,000 people doing actions in your games every second. If you need more, you can talk about that too. And then, like, let's say you have 1 terabyte of data, 2 terabyte of data, you want to analyze it, you can write a SQL query, and it will go through the whole table and give you answers like within a few seconds. So this is really what lots of game analytics use, like game analysts use. GameSys is a company in the UK which built like the whole analysis platform on top of that to find out what makes the players, maybe what was the last actions players took before they did a purchase, or what were, how can you group the players maybe in different coordinates. And the thing is, if you build a query and you don't quite get what you want, you can just fire the next one. It's not like with some less interactive clusters you have to wait hours to get a response, and then, okay, this is not what I wanted now. I have to wait a few hours again until I really get inside. So this is really cool. Cloud storage is the other one. It's basically a blob storage. You can store objects of any size and up to terabytes in size. And if you want to serve your game assets, the cool thing is if you use public files, public objects, they get cached automatically on the Google caching infrastructure. So basically, anywhere where YouTube is being cached, you can also cache like these cloud storage things. So if you have a lot of users, even in Africa somewhere, the file will get cached there, and it's really, really easily accessible. And then we have the NoSQL and SQL databases. I want to add one thing to what Robert said. You can choose if you want to use SQL or if you want to use NoSQL. Bear in mind, SQL is SQL, and it will scale like SQL. So if you want to scale to millions of users, you should probably go for the NoSQL option and just work your database that way. All right, and there's cloud endpoints, which is actually the other thing most people get excited about. It's integrated into Google App Engine, and it's made for people who are more front-end developers. They know how to develop for Android, for iOS, they know how to develop front-end, but they're not really the back-end guys. They don't want to write back-end code, and this, especially the server-client communication, is something it's not fun to do. So this is Cloud Endpoints is a way to abstract that layer. So what you do is you write your data model in App Engine, and some server-side logic. What do you want to do when a specific thing happens? What it then do, you annotate your code, and I will show it on the next slide for the coders here. And it generates a RESTful API automatically, which is actually compatible with other Google APIs. So the good thing is you can very easily use it, and there's lots of client libraries available. But we automatically generate 3 client libraries for you for Objective-C in iOS, for Java on Android, and for HTML5 JavaScript. So all the clients can talk to the server, and they don't need to care about how to encapsulate data, how to authenticate against the server, etc., because this is all abstracted. Maybe it becomes the clearest. I hope you can read this when I show you some code. So basically what I did here, I said, okay, I want to add a social layer to my game. I want to send an invitation from one player to another, so I built basically the code for that method. And then what I do is I annotate with names, game ID and player ID, the variables I have. And then I have an add API method which just says, how does the API look like I want to expose as my service. And I put game ID, player ID, invitation. So that by itself creates a RESTful API, which you can authenticate against with OAuth, so open standard. So you can build your own client library, but when we create yours, which you can do with a click of a button in Eclipse or just with one command line, then all you do from your game to call the backend, you just say something like game backend, send invitation, execute. It's a normal method call, and you get the result back, just as if it happened locally, but you actually sent the result. It gets encapsulated in JSON, the OAuth authentication happens, and it gets sent to that RESTful API, and you get the results back. So there's a few more things which we thought of when people said, okay, I like App Engine, but I don't know if I want to use it because there's constraints, and I don't know if later I don't say, oh, hadn't I used App Engine, I could use this library now. This is a little bit stupid. So we want to make this whole decision easier. I think you shouldn't have to decide between platform as a service, infrastructure as a service. We kind of try to have the best for the developer, the best of both worlds. So we introduced a concept which we call break the glass. So you can start like Robert did in App Engine, you don't need to do anything else. And then when you need more, you can start with something we call managed VMs. You just add another module to your App Engine application, and you add a little line in your configuration which says VM true. And all it does is, instead of having that module on one of our App Engine application servers, it starts up a virtual machine, and it deploys it there. So, and with that, you have quite a few advantages. First advantage, you can have much better performing machines if you need like strong computation tasks. You can have up to 16 cores. But the more exciting one, probably for you guys, is that suddenly this blacklist of or whitelist of libraries you can use falls. So you can use any library you want. You can write to the file system. You can use WebSockets to enable even real-time games. You can use everything you want. You can install any library you want with apt-get, and you have full access to the machine. So while we still manage it, so you should still not save something on the file system which you really need like a week later, because we manage the VMs. We also bring up new VMs. We shut down the old VMs if there's a software update, but you don't have the constraints anymore with the libraries, and you have the power of Compute Engine. So this is kind of our first way of making this hybrid of infrastructure as a service and platform as a service. And we have a few other steps which we discussed about. Like there will be a way, it's called replica pools, if you need a bit more flexibility. Like you want to bring up a Hadoop cluster or a Cassandra cluster, You can define what kind of servers this one consists of, and you make a template for it, and then with one basically click, you can deploy a whole instance of that. So I need another Cassandra cluster. I know this consists of 4 servers and etc. And we do health checking for that. But you don't have App Engine anymore for this one. So you can kind of choose, you want all Compute Engine, all App Engine, or something in between, and you'll have several levels. With the managed VMs, we'll also eventually be able to support many more languages, and you will be able to support your own language, your custom runtime on Google App Engine. So this is some of the exciting things which we announced. Most of them are in trusted tester now, so they should be open to the public in the next couple of months. If you're really eager to test them, you can see me afterwards, and I can see if I can do something about that. Last, I want to talk about some of our customers. We have very amazing customers, DevSpy is one. But with all of these customers comes always a story. Why they used App Engine, why they used something else, and what it enabled them to do. Snapchat is, I don't know who here uses Snapchat. Usually target user group is 20 years and younger, but some older people use it as well. It's this message service. You send pictures to another person, the other person sees the picture, and it disappears after it was seen. And that was an idea 3 guys had, and they built it on App Engine from the beginning. They found a new App Engine, he built it, and now it's 400 million pictures shared a day. It's more than, I think, more than Facebook, more than WhatsApp, more than Instagram, and it runs on App Engine. They still don't have a single person in the house who's like full-time responsible for the backend. They're a bit more than 3 people now because they have marketing and the whole stuff which comes with becoming very successful. But it's really a story. This happened like over the case of a couple of months. They only launched, I think, in 2011. Another game I always like to use, Song Pop, is a game from a small studio in New York. And they built quite a few games on App Engine, and they have a quite interesting model. They have small groups, 5 people. 5 people make one game, then they make the next game, and they try things out. They can rapidly prototype and rapidly see if something goes. If a game doesn't go at all, they just leave it and they do the next one. And Song Pop was the first big hit. It's like you listen to little snippets of a song, and then you have to say which song it is, and you play against your friends. And little snippets of songs, it's just kilobytes, but actually they serve now, I think, 80 terabytes of data a month through Google App Engine in these little song snippets. And it's also interesting because the other games don't cost them anything in letting them run, but if one gets very successful, they don't have to change anything about their big architecture. So that's their story. FEO Media is a company. They developed a game called Quiz Duel. It's the highest ranking, or it was the highest ranking game in the App Store and in the Play Store for quite a long time. It has 17 million installs, I think, in Germany now. And next week there's coming a TV show, and both the backend for the game and the TV show run on App Engine. So with the TV show, it's taking it to a new level because it will be really a usage spike during 1 hour a day, and otherwise the thing will be mostly idle. So these are a few. EA built something for Simpsons Tapped Out, which I'm madly addicted to, and Mac Interactive, they built one of these funny word games called Russell, and this became a big hit over one summer in France mostly. And the thing is, you don't also need to care about which region you're targeting because it just works everywhere. So they became a big hit. Unfortunately, they're not a big hit anymore. So also, luckily, for them, they stopped paying for this more or less. So they can start working on the next game. And then Rovio, they built their Facebook and web versions of their Angry Birds on top of Google App Engine. So this is just some examples. Fish Labs, a small studio from Germany. They built Galaxy on Fire Alliances, their first multiplayer game. This is a real-time game, and they chose Google Compute Engine for that. because they needed really low latency to the database, and they wanted to have a bit more control. Now they're very interested in this managed VM things to make the management for them easier. But at the time this wasn't out yet, so they chose Compute Engine. Yeah, that's my part of the talk, and I think we have a little bit of time for questions. So if there's any questions from the audience. Yeah.
What about push notifications? Is there a way to use it from within the app engine or integrate with third party?
Yes, you can obviously use it just from the normal app engine, just like you would if you did your own service. But on the cloud endpoints, it's further integrated, so it's very easy to do for both iOS and Android.
Okay. And this cloud endpoint, I'm not sure if I understand this correctly. This cloud endpoint is the only way to access the App Engine from the client, from the application?
So App Engine is always HTTP based. So you can build your own way of accessing it. You can build your own kind of API, or you use our RESTful API with the cloud endpoint. It just makes it a little bit easier for most people, but you don't have to use it that way. And if you want something simpler than even the cloud endpoints, if you just want to start with a simple backend, there's an example online. It's called Mobile Backend Starter, and you just deploy with one click, and you have a key value store, and you have basically all the stuff you need for a simple generic backend like that. So if you don't need to do any background computation, but you just want to store some data and bring it back later, then that's what you can use.
And I need to use it via the client's API, right?
Yes. So that comes with a sample client, and you can just use it the way. Yeah. Okay. Any other questions?
You said there's apt-get already, or
sorry?
Apt-get is already there, or
so that's part of managed VMs. It's in Trusted Tester. So if you are using App Engine, I can probably get you in. Otherwise, it will be out in months, not years.
When it comes to VMs, do you have some VMs with powerful GPUs?
We don't have GPU based currently. We don't need, so Cloud Platform is always built on something Google uses itself. That's our first thing. We might now change things for clients a little bit, but we didn't have in our own, in Google, YouTube, we had no need for GPUs, so we don't have that currently, GPU based, yeah.
When you need, for example, this GPU power for analytics, you would go with BigQuery, probably.
Yeah.
That's a much better way.
There are a few GPU use cases, but some of them you can use other things. Some of them, there are actually good GPU use cases. So we're looking at them and we're thinking about it, but nothing to report yet. Okay, any other questions?
you won't have .NET, do you?
So that's the thing with the managed VMs. There will at some point, a little bit later than the first instance of managed VMs, come something like custom runtimes. You can build your own runtime. I believe it will only be on Linux-based VMs, so you'd have to use Mono. But you could build then your own runtime on Mono, and when I say you could build it, someone else could also build it and publish how he did it. So this is could be a community effort. We can provide some samples, but we will likely. So at the moment we have no plans to have a managed by Google runtime for .NET.
What about prices for managed VMs? Will it be much more expensive?
So what we don't know yet, so it's Trusted Tester, so these things might change. At the moment you get charged for the VM prices just like you would on Compute Engine. You don't get charged extra for the App Engine part of it. So you can use the services, and obviously if you call data store, you get called for these data store writes and reads. But you don't get charged anything extra for using App Engine on top of Compute Engine right now, at least. Yeah.
From all the languages that are supported in the App Engine, which one has the most features of the code?
So Python and Java are the oldest one, and therefore also the most used ones. Go is still experimental, so it has probably the least usage. But it's still, because it's built for concurrency, it's a very good language actually to use in App Engine. And in PHP we launched last year, but we saw a very quick ramp up. Lots of people, because on PHP, and if you use the Cloud SQL, you can pretty much one-to-one port many apps which already exist. So that's why we saw a very big ramp up. But for people who build on App Engine, I would say Python and Java are the most common.
What about Dart?
What about Dart? Nothing to report right now. But obviously, given that custom runtimes come, someone can build a custom runtime on Dart. That's the minimum.
Okay.
Okay. Any other questions?
Okay, so thank you very much.
Thank you.